Welcome to the Tech Study channel. In the previous class, we have discussed about eighth important question and its answer. Only half it is completed. So, in this video, in the previous video, we have seen BJT act as a switch and amplifier. Means BJT is a one type of transistor, and we know uh, we have two types of transistors. One is BJT and FET, that is bipolar junction transistor and field effect transistor. So field effect transistor is also categorized into two, that is FET, JFET and MOSFET. JFET means field effect transistor, which is also of two type, N channel JFET and P channel JFET. And MOSFET also is of two types, D MOSFET and E MOSFET, depletion MOSFET and enhancement MOSFET. Depletion MOSFET is further divided into two, N, N channel D MOSFET and P channel D MOSFET, and E MOSFET is also further divided into two parts, N channel E MOSFET and P channel E MOSFET. So we have already seen BJT act as a switch and amplifier. We have to discuss this. Then in this we have two types. So in this class only we are discussing about, we will discuss about only JFET, okay, which is only N channel JFET. So here the ninth question is also about construction and working of JFET. So in its answer it includes JFET act as a switch and amplifier. So in this way we will complete ninth question also. So first we will see what is transistor, and then what is FET and JFET and their construction, and JFET polarities and working principle of JFET, and three regions of JFET, parameters of JFET. So construction and JFET polarities are same for both P and N channel JFETs. And working principle and three regions of JFET, only we are discussing about N channel JFET, okay, not P channel, okay. It is similar only, but in reverse will be there, reverse process will be there. And the parameters of JFET same for both P and N channel JFET, only they are differ in numerical values while calculating for each type of JFET. So first, transistor. Transistor is a fundamental semiconductor device used to switch or amplify electronic signals and power. So switching means switching on or off, and amplifying means increasing the strength of the signal. And then transistors are categorized by whether they are controlled by input current or input voltage. If they are controlled by input current, then they are called current control device. Example, BJT, bipolar junction transistor, which is completed in the previous class. And another, if they are controlled by input voltage, then they are called voltage control device. Example, FET, field effect transistor. Then what is field effect transistor means, So field effect transistor is a three-terminal semiconductor device used for switching and amplification. JFET, JFET is a one type of FET. JFET definition: three-terminal semiconductor device in which JFET is a three-terminal semiconductor device in which the current conduction is by only one type of carriers, electrons or holes. Okay. So the current conduction is controlled by the electric field between gate terminal and conducting channel of device. Here is the gate terminal. It has three terminals. I said here are their drain, gate and source. I have drawn here two types of JFETs, N channel JFET and P channel JFET. And drain, gate and source are three terminals. Okay. So as I said, the current conduction is controlled by the electric field between gate terminal and the conducting channel. Conducting channel means the whole box you have seen here. This is the conducting channel, okay, which is of N type. In N channel it is of N type, okay. In the P channel it is of P type, okay. Then the current conduction means is controlled by the gate and this gate terminal and this conducting channel, okay. And then we will see construction. It is consist of P type or N type silicon bar conducting channel containing two PN junction at sides. As I've said, in the N channel JFET, N type silicon bar will be there, which act like a conducting channel containing two PN junctions at sides. Here is the PN junction and here is the PN junction, okay. Here it is P, okay. And in the P channel JFET, the silicon bar is of P type, okay, this one, which act as a conducting channel containing two PN junctions at sides, okay. If P type bar, then it is P type JFET. If it is N type bar, then it is N channel JFET. The two PN junctions as diodes connected internally and a common terminal gate is taken out. So these two PN junctions are connected internally and gate terminal is taken out, and other source and drain are taken out from bar. This drain and source are taken out from the bar itself. This is the bar, or we can say conducting channel, okay. Then JFET polarities. So always input circuit voltage from gate to source should be reverse biased so that it has high input impedance. These two terminals, gate and source, should be reverse biased to have high input impedance. So what is input impedance? We will see now. So input impedance means is the total opposition to electrical current flow, which means resistance plus reactance offered by a circuit and its at its input terminals, okay, measured in ohms. Zin is equals to V in by I in, input voltage by input current. So how the reverse bias gate source voltage leads to high input impedance? Means in reverse bias operation the gate is made negative related to the source, okay. Means VGS is less than 0. This reverse bias voltage creates an electric field that acts in the same direction as the field due to depletion layer, which is in between the gate and channel. And then here the gate and source voltages are reverse biased. So the reverse bias voltage creates an electric field that acts in the same direction as the field due to depletion layer, which is in between the gate and channel. Gate and here the channel is there. So depletion layer will be formed like this. Here depletion layer is there. The depletion layer will be formed and it increases if the reverse bias current will be increases. So the depletion layer expands. The depletion layer acts as a very high quality insulator between the gate and the channel. That's why the input impedance is so high. Impedance means opposition to the electric current. Very few carriers can cross it, okay, leading to negligible gate current Ig. We know Zin is equals to Vgs by Ig. Since Ig is extremely small, Zin becomes very large because it is in the denominator. Then if we neglect Ig, then also Vgs Vgs is negative. So how the Zn becomes maximum means we measure the VGS in terms of magnitude. So VGN is maximum. And then here I have missed one point. Here it has low noise level. Low noise level means low noise application device means a device which has minimum amount of internal electrical noise. Okay, JFET is low noise application device because they are majority charge carriers devices. They are majority charge carrier devices means the current conduction is by a majority charge carrier which is electrons. The operate without the high current PN junctions found in BJTs. So unlike bipolar junction transistors, BJTs which requires a forward bias base current, JFET use a reverse biased PN junction. Unlike bipolar junction transistors, BJTs which require a high forward bias current, JFETs use a reverse biased PN junction for the gate. This leads to extremely low input current, which eliminates significant short noise, the dominant noise in the BJT. So JFET conducts current through the bulk means inside the semiconductor material rather than along a surface interface through or rather than through oxide interfaces like MOSFETs or forward bias junctions like BJTs. This reduces flicker noise. Flicker noise means electrical noise in circuits where the noise increases at low frequencies and decreases at frequency as frequency increase. Oxide trap means MOSFETs have a conductive channel right under a gate oxide layer SiO2. This interface contains some defects means traps. This SiO2 is also insulator. These electrons or holes passing through this channel get trapped and released by defects, causing fluctuations in the carrier number and mobility. These trapped charges randomly turn portion of the channel on and off, creating flicker noise. Forward bias junction noise means in BJTs the flicker noise generated due to electron and hole recognition at base terminal. JFET has low noise because it is a unipolar device. And the third reason is due to their structure. JFETs often exhibit lower internal resistance compared to alternative transistor and has lower thermal noise. Lower terminal noise means the noise generated by fewer voltage fluctuations caused by the random heat induced movement of charge carriers within component. Then so I have completed till here. Then this is the normal way of JFET connection. The source and drain can be interchangeable. Source can be used to drawn and vice versa. Used as drain and vice versa. The drain terminal is so biased with respect to source such that the current flows from drain to source. In every JFET, the ID is equals to IS. Working of JFET means gate is reverse biased and the two PN junctions of sides form two depletion layers, and the current conduction is by the charge carriers, in this case free electrons, is through conducting channel between two depletion layer and cutoff and out of drain. The width and hence resistance of a conducting channel is controlled by input voltage VGS. If reverse voltage is increased, the wider will be the depletion layer, narrower conducting channel, hence high resistance. The current from drain to source is decreased. Reverse will happen in VGS decreases. If VGS decreases means the magnitude of drain current ID is changeable by alternating VGS. And then cutoff region, when the VDS drain to, then we will see here what is cutoff region. So the cutoff region is the JFET is completely off. The depletion regions from B-type gate meets in the middle, effectively closing the channel so no current can flow. Conditions: the gate source voltage VGS must be more negative than or equal to the pinch off voltage VP or VGS, and VGS is equals to high negative, VDS is equals to high positive, and IS is equals to IDS is equals to low or 0. Example: VGS minus 5 and VDS 10 and ID is equals to 0. Ohmic or linear region. The JFET behaves like a voltage control device. At low VDS, the drain current ID increases linearly with the drain to source voltage VDS. Condition: VGS is between 0 volts and VGS off. VDS is low. VDS is less than or equals to VGS minus VP. So VGS is equals to low negative to VP, and VDS is equals to low positive, and ID is equals to medium positive. And for example, VGS is equals to minus 1, VDS is equals to 2, and ID is equals to 5 microamperes. Saturation region, the JFET acts as a constant current source. In this region, further increases in VDS have little to no effect on the drain current ID. JFET is used as an amplifier. And then we will see VGS is equals to low negative, VDS is equals to high positive, and ID is equals to high. VGS is equals to minus negative, VDS is equals to 15, and ID 8 microamperes. Further increase in VDS does not increase in ID. Condition: VDS is high enough to pinch off the channel. VDS is greater than or equals to VGS minus VP. So this is the JFET diagram for all the regions, and there is the graphs in cutoff region and saturation region and ohmic region. Okay, and then we will see parameters. Then parameters of JFET are transconductance. GFS is equals to delta ID by delta VGS. Drain current by change in the gate to source voltage. Then application factor is delta VDS by delta VGS, and drain resistance is delta VGS by delta ID. Then shorted gate drain current means the drain current with source shorted to gate, and the drain voltage VGS is the pinch off voltage. It is also called zero biased current. Pinch off voltage means the minimum drain voltage at which drain current becomes constant. Gate source cut off voltage means VGS, the gate source voltage where the channel completely cut off and drain current becomes 0. So that's it for today's video. If you feel this video is helpful, then like, share and comment and subscribe it. I will see you in the next class. Thank you. Bye.